Alright, I'm going to start up. I just sent you all an email that has 4 URLs in it. Sometimes some of you in here will email me and say, you have any good resources for this, whatever this happens to be. So I want to show you these. If you look up on the screen here, this first one, I'd suggest you go out here. You don't have to, but go out to codejava.net right now. All right, everybody, please just go out to codejava, one word, codejava.net. Kind of an ugly site, but it says, if you look on the side here, free Java tutorial videos. See that? They got them here and they got them here. I chose these, and once I fill that in, I just put in my name and my email. They sent me this, which was a free Udemy course with 75 lessons on it on how to get started with Java. This guy is a very, very highly rated person on here too. You can always go out and just go to Udemy or something like that, put in Java, and then if you notice, if I go and search under the free courses, there's 57 free courses. All right. So let's say, fine, you've done that, but you know you're having some trouble. I found this thing. It's called jdoodle.com, which is kind of a stupid name. It's an online Java compiler. You look up on the screen here. This is a Java program. This is what it comes with. So if I don't want to add these two, let's say that I want to multiply these two. So I'm going to say x times y. And then all I have to do is hit execute, and boom, it shows me on the bottom what the result is. So this is an online compiler. So if you ever wanted to try something to see whether or not it worked, you could always go out here and do it. And lastly, if you look here, and again, you have all these URLs. This is an online Java tutorial. All right, you're not going to do this in a day. You're not going to do this in a week. I don't know how many lessons are in here, but there are a lot of them. All right, and this is, it says Oracle now, but it was actually created by Sun Microsystems. This is, I think it's Doki. I don't remember the name, but that's something with a D, I think. But that's the mascot, Duke. That's their mascot. But it'll go through, and they call it trails, because you can go down and find out about just about anything that's in the language. A lot more than we'd have a chance to cover here. So again, for those of you who are always looking for extra resources, those are some. All right, Chapter 2 is on Java fundamentals. We did some of this. We're going to do it again. But again, I just want you to understand what it is we're talking about here. All right? Again, as I mentioned, string is not a data type. String is a class. In fact, if you look up here, this is how I find a lot of times when I'm looking for something, I'll just come out here and I type in Java string class. And I'm going to bet you the first one, there it is. That's from the API. So I go there and boom, there's the Java string class. And it looks, if you look in here, it shows you how you can create them and all the different, these are all the different string methods that you can use. All right. Comments, you already know how to do 2 of the 3 kinds of comments. // 2 forward slashes, line comment, /* ending with a / multi-line or block comment. Java also has a thing called Java doc comments. So if you look up on the screen here, that was from this morning. So there's a single line comment. There is a multi-line comment. And then lastly, Java doc comments look almost like these, except it's /*. So that is a Java doc comment. And it ends like that. Parts of a Java program, don't worry about this where it says to compile. That's if you're going to do it from the command line. Why you'd ever want to do stuff from a command line is way beyond me. You can. You can make it work. I've done it. I've taught it from a command line. To me, there's absolutely no comparison, command line versus non-command line. All right. So what do we have here? There's a single line comment. There's our class header. After that, we need our set of curlies. Then we've got our method header and our set of curlies. And then we've got our code that goes in there. All right. So there really shouldn't be anything that's in here that you can see on the screen right now, at least hopefully, that's foreign to you. We've talked about all this stuff in other languages before. The meanings are the same. The syntax between different languages, of course, won't always be the same. Every Java application must have a main method. Every one. Java applets do not have a main method. Java applets have a start method, which basically replaces main. All right. Java statements must end with a semicolon if they're an executable statement. So hopefully you have some kind of an idea. One thing about, and it's weird in this language, if I'm going to come back to here. All right. Notice in here, main in Java starts with a lowercase m. Everybody see that? It's because of that that the recommendation is that your Java methods always start with a lowercase letter. So both methods and variables look the same. The only difference is a method will have parens after it, which may or may not have something inside of them. All right? The reason I'm telling you that is C#, the methods start with a capital letter. Okay, and is it a big thing? No, but just so you know that, so you've heard it. All right. Special characters, there shouldn't be anything in here that you aren't familiar with. Okay, just like in C#, strings must be within double quotes. You have a char variable type, which is within single quotes. All right, this is how a lot of our programs are going to look. Not a true console, but you've seen it already when we've run these. Okay. Now, am I right in assuming, even with you, Colin, that everybody in this room now has the IntelliJ editor? You've all got it up and running? All right. Because if you said no, then what I was going to do is, rather than writing some code today, we were just going to go over the first. I don't want to lecture on 4 chapters. I'm not that exciting. And it just, I'd rather have you write code. I think you're going to get a lot more out of that anyway. All right, in Java, and this is in most languages, you've got 3 different things that look like this. These are all small s's. They may not look like it, but they all should be. And those stand for standard in, standard out, and standard error. Okay? By default, meaning unless told otherwise. Standard in is the keyboard. Standard out and standard error, both of these are the monitor. All right? Either at the end of this week or next week, we will write a Java program where we will change standard out so that instead of standard out going to the monitor, we'll send it to a file. All right, I've had some problems with IntelliJ getting it to, it creates the file, but it just doesn't write anything out to it. I don't know why. But I know with a bunch of you take more time than I do with that, and maybe you'll figure it out and you'll share it with all of us, including me. All right. We already talked about what an API is. Nothing new there. So, notice what this line of code right here says. System dot out means we're setting it to standard out is what it means. Dot print line. If you remember from back in the day when we were doing the C# class, all right, a year ago, I guess, right, that we did write line. Here it's print line, and it's print ln, but it's pronounced print line. Okay? And just like with write and write line, there's a print and a print line. Print line rather, does a carriage return line feed afterwards. Print leaves you on the same line. So when you look at this, system is a class, out is an object, which is a member of the system class, and print line is a method. Everybody hear that? That's, again, that's the kind of thing you could conceivably be asked that in an interview. So tell me, Ivy, in system.out.println, what do each one of those things mean? It's the system class, the out object of the system class, and the print line method of the out object. Escape sequences, we've worked with these before. Again, in what I have found, the ones you're going to use 99.9% of the time are the first two, \n and \t. Okay? There's always exceptions, but those are the ones almost always that I use. You know what a variable is already. That's why I'm whipping through a lot of this stuff. Just like in C#, and you've seen this in other languages, plus can be used as either addition or it can be used as concatenation. Okay? When I can use the same operator like this, I'm asking you this question. Okay? If I am using the same operator as both concatenation and addition, that operator has a special kind of name. Does anybody know what it is? It's an overloaded operator. The system knows that if there's two numbers, a number on each side, it's addition. If there's two strings, it's concatenation. You're going to learn how to overload not so much operators, but you will, by this time next week or right around there, you will be overloading methods. This is one of the things that you have to learn in order to become a Java programmer. So it bases it on context. All right? It looks and sees what's on the left and right-hand side of the plus sign to know whether it's concatenation or whether it's addition. Are we all clear what identifiers are? You know, an identifier is a user-defined name. It doesn't matter if it's a class name or if it's a method name or if it's a variable name or if it's a constant name. Here's a question that I've actually been asked before at interviews. Okay? And it depends on the person that you talk to, because you could actually get into arguments with people over this. So, Evan, you're going for a job as a Java programmer, and I'm interviewing you, and I say, what's the difference between a variable and a constant? You give me an answer, whatever it is. Okay? There's at least a chance that the person that you talk to will say, you're wrong. Because really, a constant is a variable. It really is. But it's a variable whose value cannot be changed once it's set. But it is, and the reason that I say that it's a variable is in here we don't use the word const like we did before. You might remember this from the end of last semester. We use the word final. But you've got to say final int, final double, etc. That's why it is a special type of variable. Here's the rules. Must start with a letter or an underscore or a $sign. I recommend 100% of the time, start it with a letter. Never use underscores in here. Never use $signs. They've done that for compatibility with other languages and with certain system variables that get created for you. In fact, I even shoot to never have digits. I like to just have identifiers that have just letters and make them as self-documenting as possible. All right. Here's the reserved words. If I count right, that's 53 of them. Like in other languages, for example, this has no meaning in JavaScript. None. The reason they made that a keyword is so you can't use it like a go-to that you use in other languages. All right. The ones that we're going to we'll look at in here, we'll go through abstract, Boolean, break, byte, case, catch, char, class, const, continue, do. So most of the ones here, double, else, enum, extends, false for, final, finally, float, if, implements, import. So almost all of them there. We won't really say much about instance of. What we'll do int, we'll do interface, long, new, null, package, private, protected, public, return. I already told you what short was, so that's most of them. So probably out of these 53 or whatever there are, we go through about 40 to 45 of them. All right. I would be amazed if you ever went for a job interview and somebody shot all 53 of these at you and didn't hire you because you only knew 90% of them, for example. All right. I don't know if I'd want to work for a place like that anyway. All right. Variable names, yeah, should be descriptive, self-documenting. Naming conventions begin with a lowercase. I prefer this. Don't use underscores at all in there. You can, but don't do it. It's just better. That's the way people do it, is like this. There's the 8 primitive data types. Same ones I showed you on the board before. All right. So you should know about the numerics. There's the ranges. I don't think you'd ever be asked anything like that in an interview. All right. You never know. There's floating points. Again, we've talked about this. Same way it is in C#, that if you make a variable a float, and if I want to say float pi equals 3.14159, I got to put an F on the end. Just the same way that you do it with floats in C#. All right. Although people who wrote C#, which came after Java, would tell you that's just a coincidence. All right. Boolean TrueFalse. Are you all familiar by now that when you use Booleans, you don't have to do this, but quite often when you create Boolean variables, you start a Boolean variable with a lowercase is union, is married. It's really making, that sends at least a subliminal signal to people looking at what you're doing. Oh, that's a Boolean variable. If you can do that, there's all sorts of notations. There are people that I know that if you've got an integer variable, they always start their integer variables with a lowercase I. Their doubles with a lowercase d, etc. Some people do that kind of thing. All right. Chars, again, single quotes. With chars, what you can put in there is like a \n. So \n is still considered a single character. If you use the Unicode, so what is it like for a capital A, I believe, is single quote \little u 0041 or something like that. Okay, that's the Unicode version of it, so you can do that. This is old. From what I've read, Unicode now has over 100,000 characters in it. All right, you can look that up if you want to know for sure, but I read that in some article someplace. I don't remember. There's Unicode. All right. That's all fine and dandy. Just like in other languages, single equal sign for assignment, double equal sign for checking for equality. Okay. I think you saw this at the end of last semester, but I want to say it again. If you look up on the screen here, please. Let's make this about, 36 should be good. Again, I think I mentioned this to you last semester. That is false. Everybody hear me? That would come out false. It would be true in C#. But what Java does is it says, are they both pointing to the same location in memory? They are not. So that is the way you would do it in C#. The way you do it in Java is you say if name1 dot equals name2. So that would be how you would do it in Java. All right? Don't use the first way, the C# way. It won't give you the right answer. Questions on that? Just like in other languages, so if this is Mary, when it's doing strings and it's doing compares, it does a lexicographical compare. They're the same, they're the same, they're the same, they're different. So it does it a character at a time. If I did this, JavaScript, or Java rather, just like other languages, it only compares apples and apples. It says these are different sizes. So it does that when it does the compare. It doesn't physically change it because it's on the right-hand side of an equal sign. But it makes a copy of it and it changes the copy. Other languages, first, again, I don't want you to do this. I want that to be over 2 lines. I want int month equal 2, semicolon, int days equal 28, semicolon. Get used to, please put some comments in your code. Even if, if we're doing it as a class and you got to go back later, I would suggest, commenting the hell out of whatever you do for your Android app, especially if it's something where you think you might be able to sell it, maybe make future versions. Believe me, you will go back to it later and you will say, why the hell did I do this? I mean, I literally have written code where I say that out loud. Why the hell did I do this? Because I have no idea. And if I didn't put a comment in there, I might not know why the hell I did that. If you do this, it says it will generate a syntax error when the code is compiled. I don't even know if that's true. That may or may not do that, but it may actually run, but you're going to get an error. All right. And Java is really bad because typically Java, until we're going to write a program where we write our own exception handlers. I've already got it written. All right. We're going to write our own exception handlers. So when stuff blows up, we'll tell it exactly what to do. The message to print out, etc. All right. But those are the kind of things. I will tell you that let's, and he's probably not, but let's say Brady goes for his app, he writes a special kind of calculator. Okay. I'm going to see if I can break it. That's one of my jobs as an instructor. I want to be able to break your code. And if you say, well, you can't. I've done everything and you can't be broken. That's good. Then it's well written. You don't want to put an app out there that you want people to conceivably use, that if they put something weird in there, that it blows up. That looks unprofessional. And even if they do buy your app, if that happens, and now you've got an upgrade, they're not going to want the upgrade because they already think they were taken. Here's your 5 operators. There shouldn't be anything new there. You also know, because we've done this in other languages, that Java, just like C#, has plus equals, minus equals, times equals, divide equals. It has the plus plus and the minus minus. You know what all those are now. All right, we've used them before. If you're doing integer division, if you do 1 divided by 2, you get 0. Why do you get 0? Why does that thing in blue right there, why does that result in 0? It's right on the bottom. Because integer divided by integer will throw away any remainder. So if I want to do this and I want it to be equal to 0.5, there's different ways I can do it. I can make one or the other. On one of these variables or other, I could put 1.0 or 2.0, or I can cast. All right. Here's your order of precedence. Exactly the same as in other languages we've used. Nothing new there at all. You can always override with parentheses. There's our combined operators. I already mentioned them to you. There's constants. We talked about those already. Okay. Just so you know, I want everybody to hear this. the first couple programs that we're writing, they're just going to be inside of a main. Everybody hear me? Everything's going to be in a main. And in the first several programs that we do, we're only going to have one file. Okay? It's just going to be one class. And that one class file will have main in it. Main is static. So everything that main talks to must also be static. Did you hear that? Then we're going to take main, pull it out, and put it in its own driver file. Then the stuff doesn't have to be static anymore. I'm going to show you several different ways of writing things. And I'll let you determine, I'll give you my own opinion, but that's what it is as far as which way is better. But when I tell you something, if you disagree and you go, you showed us two ways, you said way number 2 is better, I think way number 1 is better. It's your code. Then that's the way you should write it. Again, strings are classes. Java has no primitive string data type. All right, it's a class in the Java API. String is an example of a class, so it works that when you create strings, you're creating string objects. You're not creating regular string primitive variables. Those, if I create a byte, an int, a long, a short, a double, a float, a char, or a Boolean, those are simple or elementary variables. If you create a string, it's like an array. Those are data structures. All right? They're objects. And what's the difference? When you do this, notice what that holds. City name does not hold the word Charleston. It holds a pointer. It has the address of where Charleston lives. Languages that allow you to work with pointers are the strongest, most powerful languages there are. Java lets you work with pointers somewhat. I was going to say to a point, that's a bad pun. But Java lets you work with pointers, but they're all done in the background. The C programming language, which is my first real language that I used, they allow you to work totally with pointers. That's probably the strongest language, most powerful language there is. Back in the olden days, back in the 80s and 90s, if you ever got BSOD, which was that old blue screen of death, all right, that was typically because you had a wild pointer in C that was overwriting something. C++ also has pointers. All right. So when you create a string object, if you look on the screen here, you can do this. See that in blue? String value equals hello. When you do this, this is actually what happens. Please look. If you create it like this, this is actually what happens. Since it's an object, it must be nude. Must have a new. All right. If you don't do that with a string, that's the only one that I know of that automatically is done for you. Strings have a length. Okay, that says length paren paren. So what can you tell me about length based on what's in blue right there? It's a method. That's right. So if you try calling it and you say string, value.length without the parens, it's looking for a variable named length. There isn't one. All right? There's a lot of different string methods. Strings are mutable, which means that once you do this, if I go later on in the program and I say city name equals Wentzville, that address that's in there will change. And this will change from Charleston to Wentzville. Scope, you're going to see this in just a few minutes. Anything you declare inside of a method is local to that method. Anything that you declare outside of any method is global to the class. You're going to see that in just a couple minutes. We already talked about comments. When you create java.comments, this is what you get. If you look up on the screen here. Those are java.comments. They look almost like the API in Java. It's kind of cool. I haven't figured out yet how to make them work in IntelliJ IDEA. I'm sure you can. I just haven't taken the time to figure it out. Programming style. You should be developing your own style by now. Remember that anything that you put out on your portfolio that people are smart enough to right mouse click and choose a, like we do, view source or whatever, or if they can get to your stuff, there are people out there that will be looking and they want to see, do you document? Do you use good variable names, etc.? Do you use sound logic? That kind of thing. All right, we're going to rewrite this one with the scanner class in just a couple minutes. That'll be the only time we use scanner in here. Notice what we're doing in here. What we're saying is we want to be able to create our own. By default, all right, the system doesn't know how to get input. So we're telling it how we're going to give it input in here. After we do that, we'll do the dialog box, where we'll use the show input dialog for our input and the show message dialog for our output. They're both members of the J option pane class. All right, there's a message dialog, there's an input dialog. You saw these last semester. Typically, you always put a null there, and that first argument that's there, that's where you want it to show on the screen. By default, when you put null there, it shows it in the middle. When we start doing a little bit more advanced things, you'll need to use a system.exit to get you out of the program. Okay? And typically when you say system.exit, you say system.exit, then you put a 0 in parentheses. 0 means normal program termination. There it is. All right, converting a string into a number. We've done a little bit of this before. Integer.parseInt, double.parseDouble, etc. There are some examples. And that's it. So what we'll do is we're going to take another break. I've got some hard copies of stuff because I want to make sure I'm giving it all to you correctly, and I want to print that out during the break. And then we're going to write some code for the rest of the class today. We'll see how far we get. All right? And if we get all of it done, which we probably won't, fine. But otherwise, we'll finish it tomorrow. And if we get ahead a little bit, then tomorrow we'll go into decision structures. Guess what? Nothing new here, people. If statement, if else, switch. It works exactly the way it's worked in other languages. And if we get done with that, we'll go to loops and files. Same thing. 3 loops. You know what they are. For loop, while loop, do while loop. So again, the goal is by the end of this week, we're going to be right here. So we'll have already done 261 pages out of a 964-page text, which is a little more than a quarter. That's about where I want to be. All right. So I know it's early, but it's 2:17. Let's go till 2:30, and then when you come back, okay, then get into IntelliJ. You don't have to write anything. You can just bring it up. That's all you have to do. In fact, don't start a new project. Don't do anything special with it.